So let us see how it works. I is initially 0. Suppose the key value that I am looking for is 5. Then it will check I is less than length. Yes. Key, is it equal to a of I? That is key 5. Is it equal to a of 0? 8? No. So it will continue and say I plus plus. I will move to the next index. Then here it checks key, is it equal to a of I? 5, is it equal to a of I? That is a of 1? 9. No. So it will go to the next. So it will continue. And once it reaches here, now this time key is equal to a of I. Yes, 5 is equal to a of 7. Then return 7. So this is in case of successful search. Now what happens in case of unsuccessful search? Let us see. Initially I is 0. Suppose we are searching for 12. First it will check that key is equals to a of 0. 12, is it equal to this one? No. Then I will move to the next element. Then check key is equal to a of 1. A of 1? No. Then again I plus plus, I moves to the next element. Then again check 12, is it equal to a of this? No. So in this way it will continue and this condition will never be true. So I will move to next, then next, then next, then finally let us take this. I is less than length. Yes, length is 10 and I is 9. Yes, it is less. So key, is it equal to a of I? 12, is it equal to 2? No. Then continue I plus plus. I will move to the next location. Now I became actually 10. This I became 10 and 10 is not less than 10. So it will come out of the loop. So if it is not finding a key element, then it will come out of the loop. If at all key element is found, then it will return, means stop the procedure here itself. So if the key element is not found, then it will come out of the loop. Then outside the loop we can say return. Now, if the key element is not found, then we have to return something to show that element is not found. So the invalid index, that is -1. So we can return -1. So usually we do it like this. If the element is not found, then the return index is -1. So if you are calling this procedure, then if you got -1 means element is not found. If you got a valid index means element is found. So that's how you can know whether the search was successful or unsuccessful. So this is about linear search. Let us analyze, find out the time complexity of linear search. So one thing I will tell you about time complexity. So for finding the time complexity, either you can observe the work that is done or else you can read the code. So let us see from the procedure. What we are doing for searching, key element, checking, next check, next, next, next. So we are comparing the elements. How many elements we are comparing? At most how many? See, if I am searching for 2, then I may be performing all n comparisons, means depending on the number of elements. Or if I am searching for 8, then I may be getting an element in just one comparison. So if you look at the code now, this loop may repeat up to the end of a list, or if at all the condition is satisfied in the beginning itself, it may terminate. So this loop may repeat minimum for 1 time and maximum for n time. So the best case is that if the element that we are searching is found at first place and the time is order of 1. Best case time is 1. And the worst case is if you are searching for an element which is present at the last index and the time is order of n. So worst case is searching for last element, or the time taken for worst case is order of n. This is case of successful search. What about unsuccessful search? If the key element is not found, then always it will check all the elements, then only it can inform you the element is not there. So for unsuccessful search, time is order